Yesterday we learned the perpendicular bisector, right? And angle bisector. So look at this one. Is it the perpendicular bisector or the converse? Since everybody's yelling converse, I'm going to yell converse. Well, let's go see. All right. Perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, do not talk while I'm talking, then it is equidistant from the endpoints of the segment. The next one says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. So let's go back. Right, so since this is congruent to this, that means that these are equidistant from that point, right? Which is just the perpendicular bisector theorem, not the converse. All right, so if they are congruent, then they are equal. 3x plus 9 equals 7x minus 17. I'm going to subtract 3x. I get 9 equals 4x minus 17. So 26 equals 4x. I'm sorry, Brittany. 6.5 equals x. Everyone agree? Yeah. What's 26 divided by 4? 26 divided by 4. Right. I knew you'd get there. You're all good. All right. Now what am I going to do with my x? Plug it in. Does it really matter? No, but I can plug it into this one. 3 times 6.5 plus 9. 28.5. Thank you, ma'am. 28.5. All right, the next one. We are given that DE, which is this whole thing, equals 20.8. We are given that DG, which is from here to here, is 36.4. And we are given that EG is 36.4. What does that mean if they're numerically the same? They're congruent. So if these are congruent and I have the perpendicular, what does that mean about this down here? These are congruent, and it's the converse. Very good. So if I know the whole thing's 20.8, just divide by 2. So 20.8 divided by 2, 10.4. It's the converse because no, it gave me that the sides are congruent. Well, look at the picture. In the irregular perpendicular, okay, you have that these two little pieces are congruent. And that means if these two little pieces are congruent, then I can prove for myself that these have to be congruent. The converse, you start with these, and then you can prove for yourself that these are congruent. Okay? So converse means if they give you the legs, right? The legs on the triangle, then you can prove the bottom. All right. Oh, that's it for this. No, I hit the wrong button. Sorry, just kidding. Why don't y'all try these two on your own? That would be great. How about yes? Thanks. All right, tell me, what'd you get? Yeah, BC. If the angles are congruent, what does that tell you about these? They're congruent, right? So it's just 7.2. You angle side, right? Yeah, angle side. Yeah, I feel like I need to discuss that really fast too, P.S. And help me remember to tell Noelle and David, since they're not in here, and Nana, unless she watches the video, right? So I think there was some confusion about how you figure out what we're dealing with. So if I give you a triangle like this, Okay, and I say, how are they congruent? You know to mark this by reflexive. All of you know that, okay? But then you need to just focus on one of the triangles and then compare it to the other one, right? It's totally fine to skip one thing, either an angle or a side. What's not allowed is to skip both. Skip an angle and a side, right? So look, here's an angle. Is there anything on this side? No, so I can skip it, and then I hit an angle, and then I come down and hit a side. So that's totally fine. Have a great lunch. So before lunch, we were discussing the fact that you can skip a side or an angle, but not both, right? Stop making rackets. Thank you. So if I had an angle like this, right, it's pointless to start anywhere up here on the triangle, right? Because is there anything marked on this side or this angle or this side? No, so you start at the bottom, so you have angle, side, angle, right? Okay. That's not the best example, but the point is you can't skip two things, a side and an angle. You can only skip one. So like in this one over here, we skip this side, and then we landed on an angle. Okay? Oh. What does lol mean? Oh, laugh out loud? Lol? Really? Okay. So look at this one. Are they congruent? It's a donkey postulate. They're not congruent. Okay, I'm glad you recognize it. But here's the deal. If you start at this angle, right, and you're going up this side, so I've skipped that side, haven't I? Nothing's on it. Is there anything up here at this angle? No, so that's a bad route, right? I get it. You're not going to go through there because you get shot, right, if we're in Vietnam. Stay in the trenches. So we have an angle, then we have a side. There's nothing at this angle, right? So we would go up, and that is a side. So angle, side, side spells donkey, which means not congruent. Angle, side, side, just no. You prove that in pre-calc or calc or trig. Trig. Trig.
Is there a third side?
Side, side, side.
No, how you could prove that if two angles are congruent, the third is?
If two angles are congruent, then the third is?
Yeah. How that works?
Yeah, you probably could.
Would that not be true that two sides, the third one
Right.
at this point?
Well, you'd probably have side, angle, side, which would prove they're congruent, and then you could use side, side, side. Okay, so you asked me what you do in calculus. One of the things you do in calculus, you can find the area under an equation. Okay, so you do Riemann sum, and then you learned a faster way to do it, right? Because you always learn stuff the hard way first, and then you learn the more easy way. That's just how math works, right? So that's one of the things you'll do later. Okay, so angle, side, side, you learn why that doesn't work in trig. Calculus is a few years from now, so don't worry about it. All right, this one, y'all should have finished it before I went off on my tangent about you can only skip one thing. So find the measure of angle EFH given that EFG is 50. Oh, yes. EFG, this whole thing is 50. Now, if these sides are congruent, what does that tell you about the angles? They are congruent. So 50 divided by 2, 25 degrees. Good. Easy. 25 divided by 2, right? All right. Find the measure of angle MKL. What is wrong?
He's not being a man.
Shh. Okay. MKL. I thought somebody didn't have this page of their notes or something. That's the angle I want to find, okay? So if the segments are congruent, what does that tell you about the angles? They're congruent, so 3a plus 20 equals 2a plus 26. Subtract, I get a plus 20 equals 26, so a equals 6. How am I going to find measure of angle MKL? What's that called? I don't write plug it in if I'm doing a proof. What? Substitution. 2 times 6 plus 26 is 12 plus 26, which is 38 degrees. I'm talking about an angle. All right. Given that measure of angle WYZ is 63. WYZ is 63 degrees. And XW, which is this one, is congruent because it's 5.7, and this one is 5.7. So find the measure of angle XYZ. XYZ. Ah! That is XYW. XYZ. The whole thing. Thank you. Don't y'all fail at me. Cuz. It's not allowed. Hello, I'm human. I make mistakes. Give me a break. Okay. Shh. Love you. Be quiet. All right. What do you think? So, if the angles, if these are congruent, right? What does that tell you about the angles? They got to be congruent, so 126. Easy. This section is so easy. Since the sides are congruent, the angles are congruent. Y'all, be nice. You should ask questions. Shh. Look at it, though, and mull it over. Quit worrying about everything else. All right. So since the sides are congruent, the angles have to be. All right. Writing equations of bisectors in the coordinate plane. This requires some work, and it's going to be okay, but it does. Just accept it. All right? As a class, let's write an equation in slope-intercept form. So what does that mean? Slope-intercept. Y equals mx plus b. That's going to be my final answer. For the perpendicular bisector of the segment with endpoint 6, -5, and D, 10, 1. Perpendicular bisector. Right, so I'm going to have 6, -5, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Here's point C. And then 10, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. Here's D. So there's my line, okay? What's the perpendicular bisector going to look like? We're just going to sketch it for ourselves. It's not going to be perfect. Perpendicular bisector. It's going to go through the middle. Is there a way that we can find a point in the middle of two other points? No, not distance. A point in the middle. Yeah, midpoint. If I find the point in the middle, that's midpoint formula. Who can remind me? Midpoint formula. Okay, it is in parentheses because it's going to be a point. Add x's. Divide by 2. Good, Brittany. Add y's. Divide by 2. Everyone remember that? Can you recall that from Unit 1? Well, that's why we're reviewing stuff. Okay, so I'm going to find the point in the middle, 6 plus 10. That's going to give me 6 plus 10 divided by 2, comma, negative 5 plus 1 divided by 2. So what's my midpoint? Good, 8, negative 2. 8, negative 2. Let's look. I'll go over here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. So my point's a little off. It should have been right there. Right? Okay. So 8, negative 2. I found the point in the middle, didn't I? Now, I need a line that is perpendicular. Did we learn how to find something perpendicular to a line we have? It's the negative reciprocal of what? The slope. So you have to use midpoint and slope. You'll be all right. Promise. So what's the formula for slope? Rise over run, which means? Right. So it is the difference in the y. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Monkey tail. Remember, the y's are on top. Remember this? Okay, so I'm going to plug it in. I get 1 minus negative 5 divided by 10 minus 6. What does it mean when I have minus a negative? Plus, which gives me 6 over 4, which reduces 3 over 2. Let's go up there and look. If I go up 3 and over 2, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Is that the slope? Yeah, so what's the slope going to be of a line perpendicular to that? Negative 2 over 3. You're always going to have different signs, right? Yes, and you're always going to flip it. Now, I have a point, okay, and I have a slope. Point slope formula. Remember that? Do you see why you need to remember things you've learned previously? I just pulled stuff from Unit 1, and then I pulled stuff from Unit 3. Okay? Not y equals. It's just y minus. Have to remember that stuff, y'all. These are formulas that you must memorize. Because I'm trying to write an equation of a line. I have to plug it into this one and then solve for what? Write an equation in slope-intercept form for the perpendicular bisector. So shouldn't my final answer be like this? Why did I write that for myself? So I remember y equals mx plus b. So right now, I'm plugging it into this. So what am I going to solve for? Y. Thank you. Y. So I'm going to plug it in. Y minus negative 2. I'm using my point. Okay? I'm using this point and this slope. Because this is perpendicular bisector, right? Negative 2 over 3 times x minus 8. We have to use the perpendicular and we have to use the midpoint. That's the only way this line will be in the middle and perpendicular, right? All right, let's finish. What does that mean when I have minus a negative? Add. So right now it says y. Y plus 2 equals, can I go ahead and distribute in one step? Are y'all okay with it? All right, so I get negative 2/3 x plus, what's 2 times 8? 16 over 3. Because isn't that like saying 8 over 1? Unless you try to write an 8 instead of a 1, and then it looks terrible. Try that again. Right, negative 2 times negative 8, positive 16. 3 times 1 is 3. Good so far? All right. Now what? Bring the 2 over. Minus 2. Minus 2. So I get y equals negative 2/3 x. Y'all need to get used to fractions. Can I change this fraction?
Plus, it would be
6 over 3. So I get 16 over 3 minus 6 over 3, because 6 over 3 is 2. 16 minus 6 is 10 over 3. Get used to fractions. Let it go. Yeah, that's it. There's your answer. Because it's in y equals mx plus b. Exactly. Here's the deal. You've learned all that stuff before, right? Now you're just putting it all together. It's really okay. Perpendicular bisector. Perpendicular means I want a slope that's a negative reciprocal of what they give me. Bisector means midpoint, right? Cut it in half. Right. You have to write the equation of a line. Go ahead. All right. So write an equation in slope-intercept form. So for myself, what should I write just so I'll remember? Y equals mx plus b. Good. And then, you don't have to graph it. I kind of like to see where I'm going, though, right? So I'm going to graph it 5, 2, 1, 2, 3, 4, 5, 1, 2. And that's P. Q is 1, negative 4. So is my slope positive or negative? Positive. Now, for those of you, excuse me, my voice is cracking. For those of you that don't like to do the slope equation, you can find it by counting, can't you? What's the slope, positive or negative? Positive. 1, 2, 3, 4, 5, 6. Right? 1, 2, 3, 4. So you got when you plugged it in? That slope was 6 over 4, which is 3 over 2.
6 over 2.
But the slope's not negative. Okay, so we need to plug it in. You want me to do it real fast? Okay, I'm going to get negative 4 minus 2 divided by 5 minus 1. Negative 6 over 4. Negative 4 minus 2. Oh, should have been 1 minus 5. My bad. Ha. Sorry. Okay, negative 4 minus 2. Did you see I switched the direction I was going in? Yeah, and then 1 minus 5. It's minus. It's only plus if it's minus and negative, okay? So I get negative 6. Negative 6 over negative 4, which is 3 over 2. All right. Now I have my slope. What else am I going to do? Is this the slope that I want to use? No. So for myself, I should probably do what? Oh, yes. This is awesome. Okay, it's cool. Roll with it. So, what slope do I want? I want the slope of the perpendicular, which means flip and switch. So it's going to be negative 2 over 3. Okay, what'd y'all find for your midpoint? One plus 5 is 6, divided by 2 is 3. Negative 4 plus 2 is negative 2, divided by 2 is negative 1. So over 3, 1, 2, 3, down 1. Think that's the point in the middle? Looks like it, doesn't it? Add x's divided by 2. Add y's divided by 2. It's one of the easiest formulas you do in here. All right. Don't want to talk about it. Okay, now what should I plug it into? Right, point, slope, because I have a point that I need to use and I have the slope. Y minus, what's my y sub 1? Negative 1 equals, what's my slope? Negative 2/3 times x minus 3. So I get y plus 1, right, equals negative 2/3 x. What is 6 over 3, though? 2. Did everybody get plus 2? Good. You got 6 over 3 if you multiplied, which is just 2. Okay, now what do I do? Subtract 1. This one's way easier than the last one. You didn't have to deal with fractions. So here is my perpendicular bisector. No, because it doesn't have an x, so you can't put them together. Good? All right, here's your homework for that section, so you have it written down. I'm not going to stop. Is that okay? Good. All right. Let's keep going. Triangle midsegment theorem. All right. A midsegment. A midsegment, that's an E. Midsegment of a triangle is parallel to a side of the triangle, and its measure or length, which makes more sense to you, measure or length. Length, okay, so let's change that. And its length is equal to half the length of that side. So look, which one of those is my mid-segment? Think about the word mid-segment. A segment in the middle. So go ahead, Jamie. What is it? EB. So this is my mid-segment. And when it's a mid-segment, how do I know it was in the middle? Look at the sides. Is that mid-segment bisecting each side? Yeah, so it has to be in the middle, doesn't it? So when that happens, that means this side is parallel to this side. Parallel. Remember all that stuff you learned about parallel lines? It's going to come back. And its length is equal to half the length of that side. So that means EB is half of DC. Half of DC. That's the answer. Whatever DC is, you just half it. That's EB. It's that easy. Yep. There's no tricks. That's it. Because if we're not talking about sides and we're talking about angles, you got to bring back what you learned about parallel. Huh? Well, we are going to do that, so don't whine about it. All right, find the measure of BD. So look, here's BD. Is it the midsegment? Yes, it is, because BC is congruent to BA and DC is congruent to DE. So this is parallel to this. Okay, so BD is going to equal half of what? Half of AE. So it's going to be half of 17, which is 8.5. Good. Do I have any units of measure? Nope. So that's it. Okay. Do you see your parallel lines? How many different transversals do you have? 2. The transversal cuts 2 lines. So I have this transversal or this transversal. I should never try to use both at one time because that's confusing, right? Now, find the measure of angle CBD. Angle CBD. CBD. Ah, did I use the right set of parallel lines? Who sees what's wrong with this? Look where you're sliding. Look at your picture. Wait, Jamie, let everybody see. There's multiple parallel lines. Look, if this is parallel to this, well, here's this forest. I'm trying to help you see the trees. Here's the parallel lines, right? But now look. Look at this one right here. Why is it parallel to this? No, don't give me it looks parallel.
Because the congruent sides.
Right, because this is congruent to this. It's the mid-segment. Mid-segment, right?
Yeah.
Okay, so since this is parallel to this, you get to use those two parallel lines, right?
26 degrees.
Now, I'm going to go with these parallel and this transversal. This is 26. So what's CBD? 26. Why? Because of alternate interior angles. Never tell me because it is or it looks like it, right? No. Why? Because it's the mid-segment. They're parallel, okay? And since they're parallel, I can use everything I learned. Corresponding, alternate interior, all that stuff. It's a triangle that has 3 different sets of parallel lines. We didn't even talk about BF and CE. Yeah. So learn to pick out your trees. Did you notice when I looked at it, I thought, oh, I can't do anything with those parallel lines, right? So then I started looking at the picture to see what else is there, okay? Yes, Kaden. Yes, AF equals BD, exactly. Okay, I want to keep going. Yeah, side. All right. Don't let it blow your mind. Try this one. See if you can pick out your individual trees, because I see that forest. I get it. It's confusing. Okay? And it's okay. The 36 has no measure, like has no angle symbol, which means whatever it's right beside, it's beside the PN. Stop it. Quit being disputatious. Stop it. All right. Let me look. Find the measure of JL. So first, I'm going to find JL just because that's what I'm dealing with. All right. And are they parallel? Yes. So JL, or PN rather, equals 1/2 of JL, right? But PN is 36. How do I get rid of that 1/2? Multiply by 2, right? Most of y'all did this in your brain. You just said, oh, okay, 36 times 2. I'm just showing you algebraically, right? No big deal. So 36 times 2 is 72. JL is 72. All right, find the measure of PM. So I'm going to erase and find PM. Here's PM. Is PM parallel to LK? How do I know it's parallel? Shh. It's the mid-segment, right? Look, are these congruent? Okay. Are these congruent? Yes. So it's in the middle of both sides, right? So if it's in the middle, they're parallel, and that little one is half the big one. So PM is half of KL. Okay? You have to look at each individual thing. That's why I keep erasing my diagram and starting fresh, because you ignore all that other mess, okay? So I get half of 97, which is what? 48.5. Thank you. All right, last thing. I'm going to erase it again, and I get it. Y'all can't do that. In your homework, draw the picture 3 different times, okay? I know that's more work, but it'll help you out. Find the measure of angle MLK. MLK LK. Here's the angle I want. Now, here's this line. What do I know about this line and this line? They're parallel. Didn't I say that a while ago? Yeah, and I can use that again, can't I? Okay, so this one's 102. Then what is this? 102, and he's exactly right. It's corresponding angles. All right. Okay, we didn't get to this one. You try this one on your own, okay? It should make sense. Don't freak out. And then these are really simple too. I want you to try them, okay? It's just like what we were just doing in those problems. Oh my gosh, could I have given you any more? So, have a great day. You had that written down on your paper, so you don't have to worry about writing it. You have to do both nights worth of homework. You didn't have homework last night. Oh, that's what happens when you play extracurricular activities. Did you?